Hello Matrix. Let's talk about loss functions in machine learning, their role in training models, and how to choose the right one for your task. In machine learning, a loss function is a critical component that helps measure the difference between the predicted output and the actual output or target. By minimizing the value of the loss function, we can train our models to make better predictions. But how do we choose the right loss function, and when should we use a specific one? Don't worry, Matrix, we'll break it down together. There are many loss functions available, each with its own pros and cons. The choice of a loss function largely depends on the type of problem you're trying to solve. We'll discuss some popular loss functions and their applications. Mean squared error, MSE. This is a common loss function for regression tasks, where the goal is to predict a continuous value. MSE calculates the average squared difference between the predicted and actual values. It's sensitive to outliers, so if your data has a lot of noise, MSE might not be the best choice. Mean absolute error, MAE. Like MSE, MAE is used for regression tasks. Instead of squaring the differences, it calculates the average of the absolute differences between predictions and targets. MAE is more robust to outliers than MSE, making it a better option when dealing with noisy data. Cross-entropy loss. This loss function is used for classification tasks, where the goal is to assign an input to one of several classes. Cross-entropy measures the dissimilarity between the predicted class probabilities and the true class probabilities. It's commonly used in deep learning models like neural networks. Hinge loss. Hinge loss is typically used in support vector machine (SVM) classifiers. It measures the error in classifying the input data, penalizing predictions that are far from the true class boundary. Hinge loss works well for binary classification tasks. Now, let's talk about when not to use certain loss functions. If your problem involves predicting probabilities, MSE and MAE may not be suitable, as they don't account for the probabilistic nature of the predictions. Instead, cross-entropy loss would be a better choice. Similarly, for regression tasks, using hinge loss or cross-entropy wouldn't be appropriate. To choose the best loss function for your problem, consider the following best practices. Understand the problem type. Determine whether you're solving a classification, regression, or another type of task, and choose a loss function suited for that problem. Evaluate model performance. Experiment with different loss functions and assess your model's performance using relevant metrics. This can help you identify the most suitable loss function for your problem. Handle outliers and noise. Be aware of the sensitivity of your chosen loss function to outliers and noise in your data. If necessary, consider using a more robust loss function or pre-process your data to minimize these issues. In conclusion, loss functions are a key aspect of machine learning that helps guide our models towards better predictions. By understanding the characteristics of different loss functions and their applications, you can make informed decisions when training your own machine learning model.